Hello guys, my name is Prince and this is Math Center. Subscribe to my YouTube channel for more videos. Post your comments and questions on my social media handles and I'll respond to it. We are on the topic vectors. In the previous video, we solved an example on finding the bearing and magnitude of a column vector. In this video, we are going to solve another example. So let's look at our question for this video. Find the magnitude and direction of vector PQ, and the components of vector PQ are -3 and 4. So let's start with the first part, which is the magnitude of vector PQ. We have done quite a number of this, so I'm sure that by this time you are conversant with it. So magnitude of vector PQ is equal to square root of -3 squared plus 4 squared. Once again, don't forget to put the -3 in a bracket because it's a negative number. So this will give us square root of 25. Square root of 25 is 5, but the question told us to leave our answer in one decimal place, so 5.0 units. Let's go on to the direction. To find the direction of this vector, the first thing you need to do is to draw the diagram for the vector. The x component is negative, so you move to the left. The y component is positive, so you move upwards. So the x component is negative, so you are moving to the left, and the number is 3. So we start from P and we will move 3 to the left. We are starting from P and we will move 4 upwards because the y component is positive, so 4 upwards. We draw a line from 3, we draw a line from 4, they will meet at this point here. So that point is point Q. So the vector is vector PQ. Look at the arrow, the direction of the arrow. It's moving from P to Q. That is the vector PQ. We want the direction. Remember, we said that we take the direction or the bearing from the geographic north, which is this line here, in the clockwise direction to the line or to the vector. So it's going to be this. We are going to take the bearing from the geographic north, which is this point, to the line joining P to Q, or to the vector PQ. So this is the direction of vector PQ. Now we know that from this geographic north or the zero line to this part here is 270 degrees. That is 270 degrees. That one we already know. What we don't know is this angle. So if you're able to find this new angle and we add it to 270 degrees, we can get the direction of the vector PQ. Okay, so I'm going to call that the angle we are looking for, I'm going to call that angle theta. I use theta a lot in my examples. You can use any other variable and you can still find it. So I'm going to call that angle the angle theta. Now you will see that we are forming a right-angled triangle here, with the right angle being at this place. So if I draw a simple right-angled triangle for this, we can see that we will have the right angle here. Now moving from this point here to Q is 4, so this side will be 4. From P to this point is 3, so here is also 3. So we have opposite, which is 4, and adjacent, which is 3. So I can use tan. We know that the direction of PQ is equal to 270 degrees plus theta, as we just explained. So we are finding theta. Tan theta is equal to opposite, which is 4, divided by adjacent, which is 3. So theta is equal to tan inverse of 4 divided by 3. And tan inverse of 4 divided by 3 corrected to one decimal place is 53.1 degrees. 53.1 degrees. If you watch the video on approximations, I explained how to use your calculator to correct a number to the nearest decimal place. So if you don't know how to do that, you can watch that video and you'll be able to understand how to use your calculator to correct tan inverse of 4 over 3 to one decimal place, and that is 53.1. So the direction of vector PQ is equal to 270 degrees plus theta, which is now 53.1, and this will give us 323.1 degrees. 3 to 3.1 degrees. So we can say that vector PQ, which is -3, 4 in the column or component form, is the same as 5 units 3 to 3.1 degrees in the magnitude bearing form. So 5 units is the magnitude and 3 to 3.1 degrees is the bearing or the direction. So we solved quite a number of examples on finding the bearing and magnitude of a column vector. I'm sure you are conversant with how to solve it by now. Pick more examples and try your hands on it. Don't forget to subscribe to this channel for more videos. In the next video, we are going to learn about zero vectors and position vectors. Bye bye.